Welcome to the Hoja on Architecture podcast, Vernacular Architecture Beyond Earth, Chapter 3, Resource Responsive Design in Space. If climate taught us the limits of survival, the economy teaches us how to move, produce, and share within those limits. On Mars, the economy will not be an abstract system of numbers, but a spatial and ecological reality, an economy that architects must build, inhabit, and continuously adapt. Every civilization has mirrored its economy through architecture. Hunter-gatherers built light shelters that could vanish with the seasons. Pastoral societies raised tents that traveled with herds. Agricultural societies constructed granaries, walls, and courtyards to store and manage surplus. Industrial societies crystallized energy in steel, glass, and infrastructure. Architecture is therefore not a backdrop to the economy. It is its visible face, its physical vocabulary. The same will be true on Mars. At first, a Martian settlement will operate within a subsistence economy. Every object, airlock, greenhouse, sleeping capsule, will be designed to conserve life at the most elemental scale. Here, architecture is less about expression than it is about metabolism. Each wall becomes part of a life support loop, recycling air, filtering water, retaining heat. A single leak or failure can collapse the economy of survival. Vernacular knowledge reminds us that such early structures will resemble temporary shelters, not permanent cities, minimal, reversible, and expendable, yet vital. As production stabilizes, a second stage will emerge, a herding economy not of animals but of resources. On Mars, energy itself will migrate. Sunlight intensity shifts with the long seasons, ice deposits vary across latitude, dust storms can disrupt solar arrays for weeks. Colonists may therefore move between zones of availability, following resources much as nomadic communities once followed grazing routes. Architecture will respond through mobility, such as modular domes that detach and relocate, inflatable corridors that fold, or seasonal twin settlements connected by migratory pathways. Just as yurts, tents, and nomadic camps once embodied a rhythm between scarcity and abundance, Martian architecture may return to a similar choreography, an economy of motion. Eventually, a settled agricultural economy will take root, literally. Once food production becomes stable, the line between cultivation and construction will blur. The most radical notion is that of materials that grow, structures not manufactured but cultivated through biological or mineral processes. Imagine walls grown from mycelium networks, beams printed from algae composites, membranes woven from plant cellulose nurtured within the same domes that provide oxygen and food. Vernacular builders on Earth already practiced a version of this philosophy: bamboo forests that supplied structure, reeds that formed both baskets and roofs, and timber that renewed itself within human lifetimes. The future of Martian architecture may revive this ancient ethos, transforming the economy into an ecology. This idea redefines the concept of a resource. When material becomes renewable, production merges with maintenance. Architecture no longer consumes, it participates. The greenhouse and the workshop converge, and the builder becomes a gardener. This echoes the oldest vernacular economies, where construction was a seasonal activity tied to the rhythms of the harvest. Mud was gathered after rain, timber was cut at specific times of the year, and roofs were repaired after storms. On Mars, those rituals will become scientific cycles of growth and recycling, controlled yet poetic continuities between making and living. A fourth phase, an industrial economy, will inevitably follow, though not in the earthly sense of expansion. Industrialization on Mars will mean self-sufficiency rather than accumulation. Machines designed to repair machines, materials reprinted from waste, energy grids that feed back into life support. Architecture will externalize these processes. The settlement itself will be a living factory, every corridor a conduit of energy, and every wall a storage device. The aesthetic of such a place will not lie in ornament, but in the quiet precision of balance. Nothing wasted, nothing idle. These economic phases, subsistence, herding, agricultural, industrial, should not be read as a linear evolution, but as a simultaneous ecology. Different parts of a colony may occupy different stages simultaneously: nomadic exploration units harvesting ice, agricultural domes cultivating food and materials, and industrial cores managing recycling. Architecture will mediate among them, stitching diverse economies into one habitable landscape. The result will not be a city in the traditional sense, but a distributed organism, half village, half machine. The economy also implies the movement of people. On Earth, migration has always been both an economic and a climatic act. In the Martian context, economic migration might reappear for pragmatic reasons: to chase light during low sun seasons, to relocate for resource renewal, to avoid radiation zones. Each movement will demand new architectural typologies. Portable habitats may dominate early eras, resembling nomadic capsules that unfold and refold, allowing for easy movement. Later, dual settlements may alternate, with one occupied during periods of high solar activity and another during dormant phases. Architecture will embody time as well as space, designing not only for a place but also for a period. Vernacular parallels abound. The black tents of Bedouins, woven from goat hair, responded to heat and wind as much as to trade routes. The yurt, a circular and modular structure, allowed Mongolian herders to assemble and dismantle entire villages within hours. Even agricultural communities practiced seasonal transhumance between highlands and plains. Each of these systems fused economic rhythm with architectural adaptability. Mars may reawaken this forgotten intelligence, a return to architecture as journey, where mobility itself becomes a form of dwelling. Such movement also redefines the concepts of property and permanence. If habitats migrate, ownership dissolves into a form of stewardship. The settlement becomes a shared infrastructure, a collective resource rather than a private asset. This marks a profound ethical shift. In a closed ecosystem, hoarding poses a threat to survival. The economy becomes a practice of reciprocity, echoing the communal labor systems of vernacular societies, the Turkish imece, the Andean aini, and the African harambe. These were not merely social customs, they were architectural economies of making, where the act of building enacted a sense of solidarity. On Mars, this ethos may return out of necessity rather than nostalgia. Energy, too, acquires architectural form. Vernacular architecture often externalized energy production: courtyards for passive cooling, walls thickened for thermal storage, wind towers for ventilation. On Mars, these strategies evolve into infrastructure: solar fields, bioreactors, regolith insulation, and geothermal wells. Yet the principle remains unchanged: economy expressed as space. A settlement plan will mirror its energy loops, just as a medieval village mirrored its grain fields and mills. The geometry of survival is economic. At a deeper level, the economy also shapes aesthetics. Every architectural style has been an economy of expression. Gothic verticality reached for spiritual capital, modernism displayed industrial efficiency, and vernacular forms grounded themselves in local pragmatism. Martian architecture will aestheticize scarcity. Its charm will lie in visible restraint, the precision of fitting form to resource. A building grown rather than built, a wall shared between functions, a settlement that breathes only as much as it must. These will become the new canons of elegance. Ultimately, the study of economy in architecture is the study of interdependence. On Earth, we have often separated production from habitation, economy from ecology. In space, such divisions collapse. To survive, a settlement must integrate every act: harvesting, recycling, maintaining, into a continuous loop. Vernacular architecture already anticipated this holism. It never separated house from landscape, material from labor, or builder from dweller. Mars will remind us of this wisdom. In this context, the phrase "materials that grow" acquires both literal and moral power. It describes not only the possibility of cultivating living structures, but the necessity of designing economies that regenerate rather than exhaust. The future architect may be less a constructor and more a cultivator, managing metabolic cycles of energy and matter. Economy thus ceases to be background. It becomes architecture itself, the framework within which life, work, and meaning unfold. As the Martian village expands, its economy will reveal itself through form: modularity as exchange, flexibility as insurance, maintenance as ritual. To design an economy is to create a community. And as on Earth, those who build together will eventually believe together. In the next episode, we will turn to culture-forming design in space, where the shared labor of the economy matures into collective identity and work transforms into tradition. The vernacular village taught us how to endure. Now it teaches us how to build for worlds yet unseen. This concludes Chapter 3 of Vernacular Architecture Beyond Earth, Resource Responsive Design in Space. Thanks for listening. See you in the next episode.